Hello, today's lesson is identifying functions. This is actually part 2. So our warm-up says which graph represents a function. So remember, when you have a graph, you're going to do a vertical line test. So we're going to draw a line here, straight as possible, and we're going to go ahead and move it. If it touches in more than one spot, then that's not a function because this x value here has two different y values. Same here, it touches it twice. On this one, it touches it at every location, so that's not a function. Here, you move it across, all different, so that one is the function. So it's number 4. Our essential question is how to identify functional relationships. Today I'm identifying functions using sets of ordered pairs, tables, mappings, and graphs, so that I can determine if a relation is a function. I'll know I got it if I can analyze the data to identify a function. So we've already gone over this. This is just some different ways to look at it, different types of notes here. In order for a relation to be a function, every input must have an output. So our input, remember, is x, our output is y. Two different inputs can have the same output. So what does that look like? Let me draw a table here. And it's just saying that if we had our x and y here, if this was 2 and this was 3, and then we had x is 4, y is 3, that would be still considered a function because the x's are different. So x cannot repeat. This one input can only have one output, saying the same thing. These x's have to be different. Y's can repeat, x's cannot. So looking at this diagram here, input or domain is your x value. The function is the equation or the function. The output is your range, which is your y value. Let's just say we had a function of y equals 5x. Make it simple here. And if our, let's say x is 2, we plug in that number, 5 times 2, my output is 10. If my x was 4, 5 times 4 is 20. So you have the input, you get an output using the function. Which of these relations are functions? So we're just going to look to see if these are all different. That is, so we get a check mark for this one. Here, 6, 8, 6, those repeat, not a function. Z, Y, R, oh, Z repeats. Don't worry about those letters. It's still a type of function or relation. Sorry, it's not a function because the Z repeats. Not a function. Identify the domain and range, then tell if the relation is a function. Remember, the domain is just your input values. So I'm just going to put here, domain. Then our range. So we need to do the check to see that the x values are not repeated. There's only one line going to each one. And if you wrote those as ordered pairs, the x does not repeat, so this is a function. All right, here, if you look at 1, it has two y values, and if we wrote those as ordered pairs, 1, -2, and 1, 1, they repeat, so not a function. Identify which ones are functions. So 2, 3, 4, 7, that one is a function. They are all different x values. 1, 1, not a function. 1, 4, 9, 21, all different. It is a function. All right, we're going to do a little bit of practice with vertical line test. If it is possible for a vertical line to intersect a graph at more than one point, then the graph is not a function. So I'm going to do a vertical line. These are just plotted points on a coordinate plane, but it still works the same way. I move across here, it only touches that 1 point. Only touches 1 point. Only 1 point there and 1 point there. So this is a function. Green check. Let's check the next one. I'll make a line. Move it through. Only touches once there, but look what happens here. Touches 2 points, so that's not a function. If you wrote those as ordered pairs, you can see that the x values repeat. 1, 1, and 1, -2. These repeat, so not a function. All right, we're going to show you a series of slides next. You're going to determine if the graph is a function or not a function. So here we go. Function or not a function. So vertical line test. Oh, I'm going to do that in green. That's okay. Okay, let's see. We're going to move it across. Only touches one place all the way across. Green check. All right, another vertical line test here. Move it all the way across. Only one spot for each one. It is a function. All right, this one, let's put our vertical line in. We're good there at the beginning of it. But look what happens here. Wow, 3 different spots there, touches. So nope, not a function. This one, we'll do a vertical line test again. For graphs, we do vertical line test. Unless you want to look at all the points. All right, only touches one place all the way across. Gets a green check. This one, I'm going to do my vertical line. And you can see right away, touches more than one spot. So that is not. Okay, here. We're going to do vertical line. Oh, well, got red this time. All the way across. It only touches in one spot. So that is a function. This one, okay, so this is the y-axis, this is the x-axis, and our line is right here. So if we do the vertical line, you can see that it's right on it. So that's every point. So the y or the x values definitely repeat. So this is not a function. All right, let's look at this one. Oh, right away, look. See how that covered up so many different points, and then over here too. So not a function because the x repeats. All right, let's do this one. If you move it across, it only touches one place all the way across. So this one is a function. Okay, so I wanted to also talk about this because you're going to see this a different notation here. F of x is how it's pronounced or how it's stated. It's just the function notation. The equation notation is just the y equals 3x plus 1, so just another way to notate that, which you'll be using a lot of this when you get into high school algebra, but just know that you're going to see this in our unit, so we want to see what it's all about. If this just shows you that you can take the x, the f of x, and you plug in the input value for x. So if x was 2, f of x, or f of 2 would mean that you take the 2, 3 times 2 is 6, plus the 1 is 7. If you have f of -4, you put in the -4 for the x, you multiply 3 times -4 plus 1, that should be -11. I don't know why they forgot the negative sign there. Oh, that's too big, but anyway. Yeah, because you have 3 times -4 is -12 plus 1 is -11. Okay, so this is just before and after. This is equation format. This is function format. Look, it's the same table output. So you've got the x values. This is your input. This is your output. Let's just look at 0. I put in 0 for x. 3 times 0 is 0. 6 minus 0 is 6. These will work the same way. Same idea here. So f of 1, I would plug in the 1 here. 3 times 1 is 3. 6 minus 3 is 3. So just different ways to look at it. Oh, hold on. So there's a class kick that you can do, and if you complete it, send me a screenshot. You'll earn Narwhal bucks. All right, we got one more quick question. Which table does not show y as a function of x? Just look for when x repeats. These are all different fractions, so that is a function. Those are all different x values. That's a function. All right, look at C, look, that repeats, right? So that is not a function. That's what we're looking for. So the answer here is C. That's not a function because these repeat. All right, looking at your assignments, please make sure that you've completed the week. You're here. Here you do have a quiz, even though it's not listed here. It should be a 4.09 quiz today. Make sure you get your lesson completed, get the quiz completed. Reach out to me if you have any questions.